Yes, hello everybody. Yes, we are live again. Yes, all of you can switch to full screen mode if you are watching it from the mobile. You can switch to full screen mode and you'll be able to see. So we were discussing about, yes, we were discussing about initial momentum before collision. Initial momentum before collision. We can write this as Pi. We can write the initial momentum as Pi. Students, if you are watching the video from mobile, you can switch to full screen mode and everything will be visible to you all. Okay. Now, initial momentum before collision. See, mass of each molecule was small m. Mass of each molecule was small m. And velocity of molecule 1 along x-axis is u1. Velocity of molecule 1 along x-axis is u1. Is this part clear to you all? Okay. I hope this part is clear to you all. Now next I am writing final momentum after collision. With the same wall. With the same wall. That final momentum, mass is going to remain the same. Mass is going to remain the same. And even the velocity is going to remain the same. Just the direction is going to be reversed and we are going to have a minus sign. We are going to have a minus sign. Understood? Try to recollect. This was the diagram. I am drawing the diagram for your reference. This was O, A, B, C, D, E, F, G, correct? Then the molecule was going to collide with this wall. Molecule was going to collide with this wall. So before collision, the molecule is going to move towards right, correct? Before collision, molecule moves towards the right. Then after collision with this wall, it is going to move towards left. If it is going to move towards left after collision, then there has to be what? A negative sign. There will be a negative sign. Did you all understand this? Therefore, we can say change in momentum of the molecule that is delta P, which is P final minus P initial. That is the formula. Therefore, we can say delta P will be written as, this becomes minus of 2m u1. This becomes minus 2m u1. Students, did everybody understand this? Tell me, is it clear so far? So, we had learned up till this part that initial momentum before collision is Pi is equal to m u1, and then we have drawn this structure where it is going to collide with this particular wall. Change in momentum can be written as final minus initial. So that is delta P, which is equal to minus 2m u1. Delta P is equal to minus of 2m u1. Alright? But this is change in momentum of the molecule. This is change in momentum of the molecule. We want to find change in momentum imparted to the wall. So I'm going to mention, students write down therefore, change in momentum imparted to the wall. Change in momentum imparted to the wall is delta P is equal to plus 2m u1. Delta P will be equal to plus 2m u1. I hope this part is clear to you. Now, there is a minus sign and there is a plus sign. So why we have a difference of plus and minus? It's simple. Let us take example to understand this. This is person A and this is person B. Let us say person A is having 100 rupees with him, and then person A gives 10 rupees to person B. Person A gives 10 rupees to person B. So tell me, what is the change of money in A? Change of money in A, we can say that is minus 10. The change is negative because the value is decreasing for A, minus 10. And what is the change in money for B? It is plus 10. So if there is a wall and if molecule is colliding, with the wall, so if change in momentum of the molecule is minus 2m u1, then correspondingly what will be the change in momentum for the wall? It is going to be plus 2m u1. So I hope with this simple example you are able to understand why we have difference of signs, plus and minus. Therefore, change in momentum imparted to the wall is plus 2m u1. Now we have found out change in momentum. Now we have to calculate time. So we can say let capital T be the time taken by the molecule to collide with the same wall successively. This word is important, successively. To collide with the same wall successively. Once again, I have to draw the diagram to make you all understand this. If it would work on that digital device which I was teaching on the laptop, then it would have been easier for me to explain. But any which ways, this is the diagram. Now guys, tell me, the molecule is colliding with this wall. The molecule is going to collide with this wall. Okay. So there's this molecule. It collides. Students, how much is the distance? Each side is going to be of length L. Length of each side is L. So let T be the time taken by the molecule to collide with the same wall successively. Let us say this molecule collides at this point, strikes the wall at this point. So what will it do? It will now be reflected back in the opposite direction. And it will strike this wall at this point. This particular wall, it will strike at this point. So how much distance it has covered? It has covered a distance of L. But once again, it will rebound and once again collide at this point. So how much distance will it cover? Plus L. So can we now use the formula? That speed is distance upon time. Speed is u1 and distance is 2L and time is t. So did you understand why did I draw that diagram? I had drawn the diagram because of calculation of length. We had to calculate length 2L. So from here you'll get T as 2L upon U1. We get time. 2L upon U1. It's easy to understand this. Let us say this is wall of the container. This is wall of the container. And this is the second wall of the container. This line is the second wall of the container. So the moment molecule strikes this wall, it is going to move in the opposite direction after striking, and it is going to cover a distance of L. This distance is L. So it strikes and it covers a distance of L and it reaches here. Now once it reaches here, it is once again going to rebound. And it is going to strike the same point again. So how much distance has it covered? It has covered a distance of L plus L, which is 2L. Because we have written it should collide with the same wall successively. That is what we have written. So I hope this part is now clear, that why we have written the distance as 2L. Now we have time, we have change in momentum. So we can calculate force. How do you calculate force? You can say force is a ratio of change in momentum over time. So we can now say force is equal to change in momentum is 2 mu1 upon time. Time is how much? 2L upon u1. 2 and 2 cancels out. We get F is equal to m u1 square over L. M u1 square over L. Yes, Veer Gupta, I have explained again. Let me know whether you have understood it or not. Students, all of you all, are you all understanding this? F is equal to m u1 square upon L. Now, which force is this? This is the force acting on first molecule along x-axis, Fx1. Force acting on first molecule along x-axis. fx1. Now, once you get fx1, can we similarly let fx2, fx3 and fxn, can we write it? So first you copy this much, then we are going to erase and proceed further. Yes, hopefully the leg is clear now. Yes, now there is no lag and the screen is visible properly as well. Alright, come on, copy it down everybody. So we have fx1 is equal to m u1 square upon L. fx1 is equal to m u1 square upon L. Now we can write similar for remaining part as well. We can say similarly force for molecule to along x-axis. Force for molecule to along x-axis is equal to m u2 square upon L, and force for nth molecule along x-axis is m un square upon L. Deepak, what doubt did you ask? What is your doubt, Deepak? Okay, now one student is asking, sir, how will it be 12? How do we know that the particle will start from first wall itself and not from the middle? Arey, that is what I explained to you, beta. You all pay attention. This is the third time I am explaining now. Now guys, pay attention. This is the third time I am going to explain. That is what I did. Pay attention over here. This was the cube drawn, correct? This is the cube drawn. Now, what are we assuming first of all? Tell me, what is our assumption? We are assuming that out of n molecule, we just have one molecule. Okay, we are assuming that there is only one molecule that we had written earlier, correct? Only one molecule is there, and this molecule is moving only along x-axis. So it can start anywhere inside the container. Inside the container, this molecule can be placed anywhere, it doesn't matter. Now what this molecule will do is, this molecule will collide with this mole. It will collide with this mole. The moment it collides with this wall, you will start the timer. Suppose we have a clock timer. So beta, when will you press this button? When will you press this button? You will press this button when it collides with this wall. So timer starts and it collides. It collides at this point, let's say. So once the collision occurs, time starts. Then what happens? Then it is going to go in the opposite direction. It is going to go in the opposite direction. Time is still going on. So how much distance is this? This distance is L. Now should we stop the timer if it collides with this wall? Should we stop the timer if it collides with this wall? No. We are considering such a time such that it is going to perform successive collisions with the same wall. Okay? Then it will rebound. And it will collide once again at this point. So how much distance once again it will cover? It will cover L plus L. And the moment it collides with this wall, you will stop the timer. So when the timer started and when the timer stopped, between two successive collisions, how much is the distance covered? Distance covered is 2L. So it doesn't matter where the molecule is inside the container. The motion can be from anywhere. But you will start the timer when it collides with this wall, and you will stop the timer when it once again collides with the same wall. Okay? Alright. So force on second molecule along x-axis, force on nth molecule along x-axis. So we can now write total force along x-axis. Total force along x-axis. This total force is Fx is equal to Fx1 up till Fxn. So Fx will now be written as m by n common u1 square plus u2 square up till un square. Up till un square. This is the force acting along x-axis, total force acting along x-axis. Now students, tell me, if this is the total force along x-axis, will you be able to find total force along y-axis and z-axis? Okay, now Sumit Nikam is asking us a doubt. All of you, let's read what he has written. Sumit Nikam. Sir, we have to consider change in momentum imparted to the wall in the force formula and not minus 2m mu1. Sir, is there any reason for this? Sumit, I already explained the reason better. What is the title? What is the title? Pressure, correct? Now, who will exert pressure? Who will exert pressure? Gas will exert pressure. So gas will exert pressure on the container, correct? Gas is going to exert pressure on the container. So how much pressure will the container experience? That is what we are finding. How much pressure the container will experience? That is what we are finding. And that is the reason we have written force imparted to the wall. Students, see, the derivation is very lengthy. Okay? So I want every one of you all to pay attention better. See, I don't mind explaining everything 10 times. It's okay. I can explain it to you all. But beta, if you are paying attention, then you will understand everything. Trust me. Now, before I move further, I want every one of you all to answer honestly if you all have any doubts or not. If you have any doubts, this is the right time to ask. So just let me know, wait sir, so that I know that you are typing a doubt. Just write down wait sir, I will wait for you to type the doubt. And if you don't have any doubts, let me know so that we can proceed further. Okay, I have received reply from 3 students, Sid, Ritesh and Atul, no doubts. Remaining students, if you all can, no sir, no doubt. Okay, Vaijayanta Chalke has a doubt. Okay, Vaijayanta, tell us a doubt. Vaijayanta Chalke. ठीक है बेटा, I appreciate all your responses. I appreciate your responses, but there is one student who has a doubt. Vaijayanta Chalke. So we'll wait for that student. Type quickly, beta. Vaijayanta, type quickly. Yes. There are so many students who have written positively that they don't have any doubt. So I want you all to thank you so that you are replying. Okay, Vaijayanta is asking, sir, then formula for y and z axis will be the same now. Wait, Vaijayanta, I'm going to that part. I have not covered. What was my question? My question was that whatever we have covered, tab tak koi doubt hai kya aapko? That was my question. Okay. So, guys, come on. This is the total force along x-axis. This is the total force along x-axis. Fx is equal to m upon L, u1 square plus u2 square up till un square. So we can now write similarly total force along y-axis. Total force along y-axis, we'll write it as Fy is equal to m upon L v1 square plus v2 square up till vn square. And similarly Fz along z-axis. So we can write F Z is m upon L w1 square w2 square up. I hope this much part is clear to you all. Moving on, guys. Once we get forces, and if we divide forces with area, if we divide forces with area, we'll get pressure. So we can say therefore pressure along x-axis is Px is equal to Fx upon A. Now tell me, all of you all, tell me Fx is force along x-axis and A is area, which is L square, cross section area, which is L square. So we'll write this as m upon L into u1 square plus u2 square up till un square, the whole upon L square. The whole upon L square. Moving on, we can write this properly as pressure along x-axis is equal to m upon L cube u1 square plus u2 square up till un square. Similarly, we can write pressure along y and z axis also. So pressure along y-axis will be m upon L cube V1 square, V2 square, Vn square, and pressure along z axis will be m upon L cube W1 square, W2 square, Wn square. I hope this much part is clear to you all. Now we can calculate average pressure. Students, we can calculate average pressure on the wall. Average pressure on the wall. Therefore, average pressure on the wall, what will we say? It is P average is equal to, come on students, Px plus Py plus Pz upon 3. We can write this as 1 by 3. Now students, Px, Py and Pz, all of them have m upon L cube. So we can take m upon L cube common. And in the bracket we can write u1 square plus u2 square up till un square plus v1 square, v2 square, vn square plus w1 square, w2 square, wn square. We have written it, everybody. Moving on, guys. M upon 3L cube, and you will now write this as u1 square plus v1 square plus u2 square, v2 square, w2 square, un square, vn square, wn square. Come on, students. I hope this much part is clear to you all. Yes, Shantanu. Once you understand for x-axis, it is easy for y and z-axis. Because I am able to see students. Okay. I guess now it is visible. Yes, students, now it is visible. Just let me know because it is visible for me. I guess it is visible for me now. Better than before, at least. Better than before. Okay. Copy beta, copy it down. Copy it down. Are you all done copying everything? Okay. Students, can I erase it? Okay. Now, as you all can see, the last line that we have written is u1 square plus v1 square plus w1 square plus u2 square plus v2 square plus w2 square plus, and then there is dot dot dot. So students, tell me this. Therefore, we can say is equal to m upon 3l cube, m upon 3l cube, and in bracket we can write c1 square plus c2 square up till cn square. Come on, is it clear, everybody? Tell me, students, did you understand this? Yes, correct. Abhidanya, correct. C1 square plus C2 square plus Cn square. So average pressure is m upon 3l cube. Moving on, guys. Moving on to discuss with you all. We can introduce. Okay, there is one student in the chat who's asking that, sir, will this derivation come in examination? Yes, the derivation will come in examination. Don't worry. That is the reason I'm teaching it to you all, correct? Now, students, I'm going to introduce a concept to you all, that is mean velocity. Mean square velocity, mean square speed. Let me introduce to you all a concept called as mean square speed. Now, students, what does the meaning of the word mean mean? Mean indicates average. Mean indicates average. Mean indicates average. An average of square speed. Average of square speed. So we can represent it as c square bar. C square bar. You can represent it as c square bar. Yes, all of you all. I'll just take this more close. Probably there won't be any blur then. It won't be blur then. Now it is visible, all of you all. Now it is visible. Correct? So now I have to write in a very small space. Yes, I'll be writing from here to this portion. I'm just marking the portion that I have to write because the entire board is not visible right now. Yes, I'll be writing in this much space. Okay. Come on, students. Let's proceed now. So we can say C2 square is given by C1 square plus C2 square up till Cn square the whole upon n. Mean square speed is given by this formula. Mean square speed is given by this formula. Okay? And then there is something called as root mean square velocity. And then there is something called as root mean square velocity. Yes, Sumit is asking, sir, you had written about density. Yes, Sumit, we are going to write density. We are going to write density. Guys, I cannot zoom out because if I take it behind, again it will be blurry. So I have kept it very close to the board. And now we are going to discuss something called as root mean square velocity. Root mean square velocity. We will generally represent this with CRMS. You have done this in chemistry also. You have done this in chemistry also. Root mean square velocity. And students, the formula for CRMS is, it says this, root of C square bar. Root of C square bar. Understood, everybody? Now guys, copy this down because I'm going to erase it. Copy this and I'm going to erase it now. Copied. Okay, moving on, guys. Yes, moving on. I can say that average pressure is equal to m upon 3L cube into capital N into C square bar. I can write it like this. We can write it like this because as per the above formula, I will just write the formula that you will be able to see. We had written P average is m upon 3L cube C1 square plus C2 square up till Cn square. This is what we had written, correct? Now all of you all. So this can be written as n into C square bar. So we can say P average will now be written as mn upon 3L cube C square bar. This can be rearranged and written as 1 by 3 m into n is capital M, L cube is volume, and mass upon volume is density. So this can be written as 1 upon 3 rho C square bar. And if you want to replace this in terms of RMS, students, you can also write it in terms of RMS as 1 by 3 rho C square RMS. So this or this, two formulas we have. And this is where we end our derivation. Come on, understood, students? Just let me know whether you have understood the derivation or not. Yes, the derivation was very lengthy, agreed to it. But if you try to think of it logically, it is easy. If you have understood, then it is easy. Yes, Atul, these type of derivations were asked earlier. Yes, these types of derivation were asked earlier in the board examination. Copy it down quickly and we can start with the next part. Okay. I'm going to erase this now. I will give you all 2 minutes, everybody. Just go through the derivation once, go through it. Probably 2 to 3 pages, the derivation is of. Go through it. If you have doubts, ask me. If not, let me know that sir we don't have any doubts, so that I can start with the next topic. Yes, Shantanu is asking us a doubt. Why did we replace? We have replaced it because of the formula written on the first page. We have replaced it because of the formula written on the first page. Yes, moving on, guys. We are going to learn relation. We are going to learn relation. We are going to learn relation between CRMS and capital T. Between CRMS and capital T. Now come on, what was the formula? Pressure is 1 by 3 rho C square RMS, that is the formula. Students, I don't think so there is lag. It is clear for me. I don't know why are you typing lag. Any which ways, we can take V over here. Then we can say PV is equal to 1 by 3 M C square RMS. Now we know PV is nRT, correct all of you all? So we can replace PV with nRT, which is equal to 1 by 3 M C square RMS. Now students, if number of moles is 1, then RT, rather 3RT will be M into C square RMS. I hope this part is now clear to you all. When we rearrange this, we can say on rearranging, therefore, C square RMS is 3RT by M. And therefore we can say that CRMS is given by under the root of 3RT over M. A very important formula. A very important formula. Root of 3RT by M. Yes, I told you earlier also, beta, that you have done this in chemistry. I know that you have done this in chemistry. Nonetheless, I have explained it to you all. And what is capital M, beta? Capital M is molar mass. Capital M is molar mass. Now, students, let's compare this formula with the formula for speed of sound. Let us compare this formula with the formula for speed of sound. We can say since speed of sound is given by V is equal to under the root of gamma RT upon M. I hope you remember this formula. Of course, whenever we talk about speed of sound, we always use which formula? Laplace formula, because Newton formula is wrong. So V is equal to root of gamma RT by M. Now, if you compare, you can say CRMS upon V is equal to root of 3 by gamma. Root of 3 by gamma. Now, students, we will say that therefore speed of sound is always root of gamma by 3 into CRMS. Just keep this formula in mind. Keep this formula in mind. Is this additional relation clear to you all? Understood? Okay, moving on, guys. Now write down the next heading, next title. Write down the next title as interpretation of temperature in kinetic energy, in kinetic theory of gas. Interpretation of temperature in kinetic theory of gas. Now, students, understand this. Okay. Okay, Yash Sharma is asking us a doubt that, sir, you missed out Boltzmann constant in the relation between C and T. No, Yash, this is the formula. CRMS is root of 3 RT by M. Clearly, this is the formula. If you are going to write K, then you have to have Avogadro's number. You should have Avogadro's number. And we have considered number of moles as 1. We have considered number of moles as 1. Now, some student, Anna Balagan Virmurthu, is asking, sir, image not clear, just move. Which image are you talking about, beta? Which image? There is one more student saying, sir, I have a doubt. Yes, what doubt you have? Hari, what doubt you have? Okay, Hari, you typed it out. Till that time, I explain the next concept. Now, students, what I was saying is that when we talk about temperature, whenever temperature increases, it means that heat energy also increases. And that heat energy is nothing but kinetic energy of molecules. That is nothing but kinetic energy of molecules. Do you understand this? So when temperature increases, heat energy increases. And whenever heat energy increases, it means kinetic energy of the molecules increases. So temperature is related to kinetic energy. Therefore, we can say temperature is related to kinetic energy. Now, students, tell me P is equal to 1 by 3 rho C square RMS is the formula. We can rearrange this and say 3P, density is mass upon volume, into C square RMS. Now multiply by half on both the sides. So you'll get 3 by 2 PV is half M C square RMS. And which energy is this? This is total kinetic energy of the gas. Total kinetic energy is 3 by 2 PV. So we can say kinetic energy can also be written as 3 by 2 PV or 3 by 2 nRT. Two formulas we have. Yes, this is translational kinetic energy. Correct. Hari, how it can be? Hari is asking how it can be. How it can be what? Okay, moving on, guys. We can also write the formula for, based on this formula, we can also write for kinetic energy per mole or kilomole, and the formula will be 3 by 2 RT. The formula will be 3 by 2 RT. Formula is 3 by 2 RT. Kinetic energy per molecule is 3 by 2 RT upon Na, because we are writing per molecule, so we have to divide it with Avogadro's number, which is 3 by 2 kBT, kinetic energy per molecule. So I hope the concept of kinetic energy is clear to you all. Students, the concept of kinetic energy, I hope it is clear to you all. Now copy it quickly. Okay. Now Hari was asking us a doubt. Hari, you have not written your doubt. What doubt do you have? Hari, what doubt do you have? You have not written. Let us know your doubts. Hari Netra, let us know your doubts. Okay, I believe that Hari doesn't have any doubt. So in this case, we are going to end the lecture here. So we'll be meeting again on Monday. Till then, study this properly and stay safe. Okay. All right.